In this module, we will learn about sets. In everyday life, we often speak of collection of objects of a particular kind, such as a pack of cards, a crowd of people, a cricket team, etc. In mathematics also, we come across collections. For example, of natural numbers, points, prime numbers, etc. More specially, we examine the following collections. 1. Odd natural numbers less than 10, that is 1, 3, 5, 7, 9. 2. The rivers of India. 3. The vowels in the English alphabet, namely A, E, I, O, U. 4. Various kinds of triangles. 5. Prime factors of 210, namely 2, 3, 5, and 7. 6. The solution of the equation x squared minus 5x plus 6 is equal to 0, which are 2 and 3. We note that each of the above example is a well-defined collection of objects, in the sense that we can definitely decide whether a given particular object belongs to a given collection or not. For example, we can say that the river Nile does not belong to the collection of rivers of India. On the other hand, the river Ganga does belong to this collection. We give below a few more examples of sets used particularly in mathematics, which are n is equal to the set of all natural numbers, z is equal to the set of all integers, q is equal to the set of all rational numbers, r is equal to the set of real numbers, z plus is equal to the set of positive integers, q plus is equal to the set of positive rational numbers, and r plus is equal to the set of positive real numbers. The symbols for the special sets given above will be referred to throughout this text. The collection of 5 most renowned mathematicians of the world is not well defined, because the criterion for determining a mathematician as most renowned may vary from person to person. Thus, it is not a well-defined collection. We shall say that a set is a well-defined collection of objects. The following points may be noted. 1. Objects, elements, and members of a set are synonymous terms. 2. Sets are usually denoted by capital letters A, B, C, X, Y, Z, etc. 3. The elements of a set are represented by small letters A, B, C, X, Y, Z, etc. If A is an element of a set A, we say that A belongs to A. The Greek symbol epsilon is used to denote the phrase belongs to. Thus we write A epsilon A. If B is not an element of a set A, we write B does not belong to A. Thus, in the set V of vowels in the English alphabet, A belongs to V, but B does not belong to V. In the set P of prime factors of 30, 3 belongs to P, but 15 does not belong to P.